different student. Okay,
Yes.
fine. So, should we start for today? Since you have it on the 22nd of September, I think we have enough time. We can revise it, even if we do not start it today.
Okay, ma'am.
Okay. But tell me, how about your, like, how is your understanding of those two chapters? Any confusion in that chapter as such, or you just want a revision just to cover up the, just to have an
Just
idea for the.
ma'am.
Okay, fine. No conceptual problem as such, right?
No, ma'am.
No, fine. Then hopefully we'll start it in the next one. Then we'll be able to finish it up. We'll just take the important questions so that you will also revise the questions, and then obviously through the questions, the concepts will be revised very easily. Fine.
Okay.
But before doing that, what you will do is that from your side, before starting the lecture for the revision, classes and the questions, what you will do is that before starting that, you will go through the NCRT and your syllabus properly. You will revise it properly. So then when you are attempting the questions, it is actually in your mind, what are we actually going to do? Right?
Okay, ma'am.
So today I think we should start back with our topic, that is of atomic mass.
Yes, ma'am.
Yes. What did we discuss regarding the atomic mass? Yes, Harshita. Any idea for that?
Uh,
No worries. Acha, tell me, just define me the simple part. What is
we
atomic
were
mass?
just we were just talking about like the units.
No worries. Just tell me, what is atomic mass? What do we mean by the atomic mass? What is atomic mass?
Atomic mass is uh,
Mass of the
the mass of the atom or
mass of
molecule.
the atom. Mass of the atom, beta.
Okay,
Just the
ma'am.
atom as of now. Okay. Atomic mass
Yes.
is the mass of the atom. Fine. And we know that the atom is very, 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 very small. Okay. But
Yes.
how do we measure that? How do we measure that? Therefore, we developed a method in which we are not taking the absolute mass. Absolute means not taking exactly the mass of that. We are taking the mass in reference to some other quantity that we have fixed as the standard or the reference point. Yes.
Okay.
Therefore, we said we are taking the mass in relation to that quantity. Therefore, we
Yes.
have the term relative atomic mass. The atomic mass is called as the relative atomic mass because we are taking that as a relative quantity to some other quantity, some other unit. Yes, I'll explain that again.
Yes.
No worries. Are you able to
Okay.
recall some of it? I think I should start from the beginning, or are you able to recall that? Tell me, beta. Whatever,
Ma'am, I can recall some of them actually.
somehow. So I think we should start from the beginning. We'll take the concepts and then we'll not say that twice or thrice. We'll just say it once and then hopefully we'll be able to
Uh,
recall.
yes.
And then the point was, let's say we have this one atom, okay? We have this one atom. We have another atom, okay? This green colored atom. Obviously, the size might be different. The size would be different because these two are different atoms. But overall, the size for both of the atoms would be very, 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 very small, okay? Now, how do I measure the mass of both of these two different atoms? What do I do is that I fix this mass somewhere, okay? I take this mass somehow, okay? And then I fix this mass. Let's say this is X, okay? The mass came out to be X, and I fix this mass of this one atom as the unit. Okay, this becomes 1 unit. Clear? This becomes 1 unit. Right? Whatever the quantity is this becomes 1 unit. Right? Now, when I measure the mass of this blue atom, okay, this was coming out 2 times the mass of this atom. This was coming out to be 2 times the mass of this atom. Therefore, what will be the mass for blue atom? I will say 2 units. What was the unit here? The mass of this atom. Are you getting it?
Yes.
Yes. Let's say we measured the mass of this green atom, okay, and it came out to be six times the mass of this atom. Yes, it came
Yes.
out to be 6 times the mass of this atom. I did not know what the mass was. I just got to know that let's say beta, this was coming out to be 6. Okay, let's assume. I'm just giving the example. Okay, the mass of this black atom came out to be 6. Okay, and the mass of this green atom, okay, came out to be 36. Okay, what will I say? Can I say it is 6 times the mass of this mass? Yes or no? This is just an example to explain. Therefore, what becomes the unit here? The unit here becomes the mass of this one atom. Are you getting it? What are we doing here? We have fixed one quantity. We have fixed one quantity, okay? And we are measuring the masses of other atoms here in this case, okay? Other atoms in relation to this mass of this one atom. Is it clear?
Okay.
And
Yes,
that
ma'am.
is why it is called as relative. What is relative? In relation to something else, okay? That is relative. Okay. I'll
Okay.
explain you this concept of relative through the speed, okay? If I'm just
Yes.
saying I am riding a, I'm driving a car, okay? I'm driving a car.
Okay.
Let's say my speed is 40 kilometers per hour. Let's say that, okay?
Okay,
How do
ma'am.
I know whether I'm driving fast or slowly? How will I know that? Until and unless I have some other car who is driving at a speed of 60 kilometers per hour. In relation to that car, I can say I'm driving slowly. Are you getting it?
Yes.
But if I have another car, let's say who is driving at 20 kilometers per hour, in relation to that car, I'm driving fast. Are you getting this relation?
Yes, ma'am.
Okay. So relative means this. We are taking whatever we want to know in relation to some other object or some other unit. Then only we are able to compare. Okay. See,
Okay.
let's say the unit is X, that is mass of this atom, and this we are taking as the unit. Okay. Let's say we have any other atom. Okay, any other atom, and when we measure the
Yes.
mass of this different atom, let's call this V. Okay, it was coming out half times, half times this mass. Okay, half times
Yes.
this mass. Can I say it is just I'm giving the example. This is not the case. Okay, zero point 0.5 units. Are you getting it?
Okay, ma'am.
Yes. So have you
Yes.
understood the term relative?
Yes, ma'am. I have.
Fine. What are the two things that we need in relative? We need to fix one standard quantity. We need to fix one standard quantity. In this case, I took the mass of one atom. I might take the mass of half atom, then I can fix it. Yes. I might take the
Yes.
mass of two atoms, then I can fix that as the standard quantity. So its standard quantity could be fixed according to the convenience and the need. Correct?
Okay, ma'am.
Fine. Now coming to the actual atomic mass. Okay. Atomic mass. And we know it is relative in nature. Yes. It is
Yes, ma'am.
relative in nature. So we saw in the above example, we need one standard quantity. Okay, beta. What have we
Yes, ma'am.
fixed as the standard quantity? See, we took one atom and the name of that atom is carbon 12 atom. Okay. We took one atom and
Yes.
the name of that carbon atom is carbon 12. Let's
Oh,
draw the atom something like this. This is the atom. Okay. Now what happens is that we took the mass of this atom. Fine. That is not our concern. We divide this atom into 12 pieces. How many pieces?
12 pieces.
12. Okay, something like this. Okay, just see that. Okay, 12 pieces. Now what happens? The mass came out to be example 12. Okay, let's say it
Oh,
came out to be X. Okay, what will happen if I've divided the atom into equal 12 pieces? The mass of each piece
yes,
will
ma'am.
be X divided by 12. Yes or no?
Yes, ma'am.
Each piece, since they have been divided into equal pieces, the mass of each piece would be X divided by 12, right? Now we
Yes, ma'am.
have taken this as the unit. We have taken this
Oh,
as the unit. Clear? How do I write it? I say 1/12, 1/12, the mass of, I will explain you this normally, the mass of carbon 12 atom. This is my unit. Are you getting this? Unit here simply means the standard quantity that I am taking, the standard point, the reference point.
okay, ma'am.
1/12. Whatever the mass of carbon 12 atom came, we have divided that by 12 and that we are taking as the standard reference point. Any confusion in this, Harshita?
No, ma'am. I
No?
got it.
Fine. Now see, if I ask you one thing, think and then say, okay? If I ask you one thing, we have taken this as the unit, okay? Now if I measure the mass of this carbon 12 atom, the mass of this carbon 12 atom, yeah, what will be the
Yes.
mass, what the mass will come out to be since we have taken this atom? Think and then answer. I'll give you this hint, okay?
56.
Okay, can you explain me why?
It's because
Say that. Please do not
it's
hesitate, Harshita. Yes, say that.
ma'am, because
Mm-hmm. Say that.
it's a atomic mass of it actually, ma'am. That's why.
Is the atomic mass
Yeah, ma'am, it's
of?
an atomic mass of the carbon.
That is the atomic number of carbon. You confuse the two, huh? You got to know the atomic number of carbon and you said that for the atomic mass of carbon. No worries. I am asking
Uh,
you based on this, whatever we have discussed right now. Based on that, can you tell me, can you take a guess? Can you try that what will be the mass of this carbon atom? Hmm. You know it. See,
Now it's 16.
16. How? Because you have learned that the mass of any atom is close to 16 and that is oxygen. Okay, that is wrong. See,
Okay.
we'll discuss. See what I'm saying.
Okay.
But we had this atom and the name of this atom was carbon 12. Okay, try to think it that way. And we divide this into 12 pieces, something like this. Hopefully I get equal pieces this time. I don't think so I'm getting something like that.
Yes.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Fine. Okay. Out of this, we took one piece. Okay. Assume all of them are equal. Okay. We took one piece, something like this. Clear?
Yes,
And
ma'am.
the mass of this one piece, okay, became the unit. Clear? Became the
Okay.
unit. What we were doing in the relative thing, what we are measuring the whatever quantity we have, okay, we are measuring that in number of times of this mass. Yes, what we were doing. Let's say I have any other atom, the mass came out to be 2 times of this mass, right? Because this is the unit. 2 meters, that means 2 times of 1 meter. I'm getting that. If I'm
Okay,
saying
ma'am.
length is 2 meters, what do I mean? I mean 2 times of 1 meter. Yes, yes or no? Because the unit is
Yes.
meter there. Here, if I am saying, see, this is one piece here, right? This is one piece. In this atom, beta, in this atom, how many times is this piece being repeated? In this atom of carbon 12.
Yes.
You know it. How many times is this one piece being repeated in this atom of carbon 12 atom?
Mm, 12
I said
times. Mm,
exactly 12 times. Excellent.
Okay.
Because we have divided that atom into 12 equal pieces. Yes. Don't you
Okay.
think, let's assume this is the unit, this is X, okay, this is the unit. Don't you think the mass of this atom would be 12 units? Yes or no? Yes or no? Because that
Yes.
piece is being repeated 12 times. Have you understood this?
Yes, ma'am.
Something, any problem here? Should I repeat this?
I got it, ma'am.
You got it. What are we doing? We are measuring this in relation to that one unit. Now, in this case, incidentally, what happened? The unit was being repeated 12 times. Therefore, we get the mass as 12 units. Just a second.
Yes, ma'am.
Okay. Therefore, we get the mass as 12 units. Clear? What is the unit here? This one piece is the unit here. Any
Okay.
confusion here, beta? See,
No,
that is
ma'am.
why we say carbon 12 atom being divided into 12 pieces will definitely have the mass as 12 units. And that is why carbon has an atomic mass of 12 and not 6. Okay. 6 is the atomic number. We'll discuss what is atomic number. Clear?
Mm,
Fine. If I say, can you tell me what will be the mass of this? Just try to guess this. What will be the mass of this? Whatever quantity I have, can you tell me the mass here?
Um,
What do
ma'am,
I
is it,
have here? Yeah. Yes, yes, say that, say that.
ma'am, is it 24 units?
Excellent, excellent.
Okay, ma'am.
24 units. Clear? 24 units. Fine.
Yes.
Fine. Now, in the similar manner, when we measure the mass of one oxygen atom, okay, one oxygen atom. Please pay attention to the terms that I'm using. I'm using the term atom here and not element, molecule, or compound. Okay. Oxygen atom came out to be 16 times 1/12 the mass of, you will tell me the mass of
Mass of carbon.
12 atom. Okay. Yeah.
Okay, ma'am.
Therefore, this was the unit, beta. This was the unit. Can I say it is 16 units, beta?
Yes, ma'am.
Fine.
Yes, ma'am.
The mass of one nitrogen atom is 14 units. The mass of one nitrogen atom is 14 units. Can you tell me what
Okay,
do I
ma'am.
mean by that? If I'm saying the mass of nitrogen atom is 14 units,
It is 14 times 1 by 12th of the mass of carbon.
can I say that one piece out of the 12 pieces that I got, that one piece, okay, something like this in the shape of a pizza slice, okay,
Yes,
this
ma'am.
is being repeated 14 times, and that is equal to the mass of the nitrogen atom. Do you agree with that?
Yes, ma'am.
Clear?
Yes, ma'am. It is clear.
Now, if I take the mass of the hydrogen atom, beta, okay, hydrogen atom, okay, what will happen here? It came out to be 1 unit. 1 unit. Okay. What does this mean?
Mm.
Hmm. Yes. Yes. You know it. Say that.
Mm.
Hmm.
It's just only made up of only one of it.
One. One. Harshita,
One.
have I scolded you ever?
What, ma'am?
Have I ever scolded you?
No, ma'am.
Then why do you hesitate so much in answering, huh?
Um,
Just say whatever point you have in your mind. Trust me, that will help you to clear your doubts. Okay.
Ma'am, it's just one of its atomic number.
Atomic number. Where has the atomic number come from, huh? Beta. What is the unit? Unit is this one piece of carbon 12 atom, yes? This one
Yes,
piece
ma'am.
of carbon. That means the mass of this one piece of the carbon 12 atom, or 1/12 the mass of carbon 12 atom, okay? 1/12 the mass
Yes.
of carbon 12 atom is nothing but is equal to the mass of one hydrogen atom. That is why we are saying 1 unit. Yes.
Okay, ma'am.
What was the confusion here? Just remove atomic number as of now from your mind. Then only you will be able to understand atomic mass. Atomic number and atomic masses, these are two separate, completely different things. Do not confuse them.
Okay, ma'am.
Right? Is
Yes.
it understood now? If I'm
Yes, ma'am.
saying if I'm saying the mass of helium is written as 2 units, explain me what do we mean by this?
It is like 2 times the mass of the 1 by 2 of carbon
One by
dioxide. 1
carbon
by 12.
dioxide,
1 by
uh,
12.
1/12 of
The carbon dioxide's mass.
Ashita, beta, carbon.
Carbon
What
dioxide.
you said carbon dioxide mass. It's carbon
Okay.
12 atoms mass. Okay,
Yes, ma'am.
fine. Okay. Did you have your favorite meal right now? Yes or no? Tell me that. What's your favorite meal, by the way? Where are you from in India?
Tamil Nadu.
Oh, you are a Tamil. Great. So Tamils have a great taste, huh?
Yes,
Yes.
ma'am.
Yeah. What's your favorite food from there? Meal.
Um, exactly. I have many favorite dishes though.
That's fine. That's the case with every human. Yes. But let's name two of them. Name two of them.
Okay. For me, puri, then dosa is my favorite.
Dosa. Did you just say
Yes,
dosa?
ma'am.
Let
Yes,
me
ma'am.
just tell you, I love dosa. Okay. I love dosa like anything. They are my comfort food. Okay.
Okay, ma'am.
So when was the last time you had your favorite dosa?
Today morning, actually.
Then you should be energetic. Fine.
Okay,
You
ma'am.
are meant to be. You're bounded to be like energetic since you have had your favorite meal dosa. Yeah.
Yes, ma'am.
Is it okay?
Okay, ma'am.
And I'm glad to know that whenever I ask other students what's your favorite meal, they generally say it's pizza, pasta, or burger, something like that. I'm glad to
Okay.
know that someone actually from South India has said that it's dosa as their favorite meal. So small claps for that. Okay. Any other favorite food that you have that will come in the category of junk food, huh?
Category, ma'am, I don't like junk food actually.
Excellent. That's it. Fine.
Okay,
That's
ma'am.
the best thing. So you don't really eat junk food. That's the best
No, ma'am.
part. Excellent. Great. So you don't like burgers and the pizzas and the pastas, all of that.
No, ma'am.
You are a typical desi person, huh, in eating, and that's the best part. Coming back to our atomic masses. Fine.
Okay, ma'am.
If I am saying helium is equal to 2 units, beta, can I represent it something like this? 1. In the earlier standard, you must have, like, you must remember that we used to draw something like this, right? 1, 2, 3 units in like
Yes,
three,
ma'am.
third, and the fourth standard. So can I draw it like this? Can I represent the mass of the helium atom, something like this? Yes. Because two
Yes,
times this part is being repeated. Yes.
yes, ma'am.
If I'm drawing hydrogen, can I just draw it one? Because since it's 1 unit, can I draw it like this? The mass of this will be equal to this. If I'm drawing oxygen, yes, it's 16 units. So if I draw this, beta, 16 times, the mass will be equal to this. Yes, beta, the mass will be equal to the oxygen atom. Yes or no?
Yes, ma'am.
Have you understood this now?
Yes, ma'am. I understood it.
The mass of sodium atom, I'm just telling you, the mass of sodium atom is 23 units. What do we mean by this?
Uh, it means that it is 23 times
Mm-hmm.
by 1/12 the mass of the carbon dioxide.
What has happened to carbon dioxide?
Carbon,
Huh?
carbon atom.
12, carbon 12 atom. Okay,
Okay,
carbon
ma'am.
12. Wonderful. Excellent. Fine.
Yes,
Coming back to our NCRT now. You have your NCRT?
yes, ma'am.
Hello? Yes. Is it better
Yes, ma'am.
now? What
Yes,
happened?
ma'am.
Okay, my network is unstable. Fine. Yes. So
Okay.
coming back to first of all, I'll be starting from this point, then we'll go back to the earlier points. Okay. In
Okay.
1961, for a universally accepted atomic mass unit, I'm continuously saying atomic mass unit means what? The unit of the atomic mass. Meter is what? The unit of the length. So here we need a unit of the atomic mass. Okay.
Yes,
Carbon
ma'am.
12 isotope. We have already discussed isotopes. Okay. And I think I told you that carbon 12 is an isotope of carbon. We discussed this. Okay.
Yes, ma'am.
Carbon 12 isotope was chosen as the standard reference for measuring atomic masses. Harshita, any problem in this point?
No, ma'am. I got it.
One atomic mass unit. One atomic mass unit, let's read this very carefully. One atomic mass unit, that is the unit of the atomic mass when we are having the value 1 unit. Okay, 1 times of that unit is a mass unit equal to exactly 1/12 the mass of one atom of carbon 12. Yes,
Yes, ma'am.
okay. So basically, 1 unit is something like this. If I try to represent this, 1 unit is this. Okay, 1 unit. That's it. What is this? 1/12 the mass of carbon 12 atom. Clear, beta?
Yes, ma'am.
And
Yes,
this is
ma'am.
nothing but the atomic mass unit. This is nothing but the atomic mass unit. Okay. The
Okay.
relative atomic masses. See, the relative atomic masses of all elements have been found with respect to an atom of carbon 12. In respect to this, we took this as the standard quantity and then we measured the mass of other elements in respect to this. We have already discussed this, beta. Yes.
Yes, ma'am.
See, although this is a good example, you might go through this. Imagine a fruit seller selling fruits without any standard weight with him. Obviously, the problem would be there. How does he measure the exact weight? If I want 2 kgs, let's say he gives me 3 watermelons, and if you want 3 kgs, let's say he just gives you one watermelon, saying it's of 2 kgs. But how do we know that it is exactly of 2 kgs? Okay. He takes the watermelon and says this has a mass equal to 12 units. He does that. He says that he takes this one watermelon, okay, and he said that this mass of this watermelon, okay, is equal to 12 units. Still, the units have not been defined, okay. He makes 12 equal pieces of the watermelon and finds the mass of each fruit he's selling in respect to this, okay. If he had said this is the standard weight, okay, what will I say? If I say I want 3 units, okay, I want 3 units, then he should give me, okay, 3 particles, I mean 3 units of this. Is it okay? Because
Yes,
this
ma'am.
has been the standard unit. Is it clear?
Yes, ma'am.
Relative to the mass of one piece. So this has basically become the standard quantity. Clear? This has become the unit now. This has become
Okay.
the unit now. Fine. I will not say I have bought 2 kgs of the watermelon. I will say I have bought 2 times the mass of this unit. Okay, the watermelon. Clear?
Okay, ma'am.
Now he sells his fruits by the relative fruit mass unit. I mean, in case of atoms, they've used the fruit mass unit. Clear, beta? Similarly, the
Yes.
relative atomic masses of the atom of an element is defined, important, is defined as the average mass of the atom. Average mass of the atom, I'll discuss this, as compared to 1/12 the mass of carbon 12 atom. We compared this, right? And it came out to be
Yes.
16 times for oxygen. It came out to be 14 times for nitrogen. It came out to be 1 time for hydrogen, yes?
Yes, ma'am.
And see, we take the, it is written as average mass, beta. Why do we say average mass? See, when we found that isotopes are present, yes, what were isotopes? Can you tell me?
Um,
No worries.
it's
You must be busy for revising the half yearly syllabus. No worries. Isotopes
uh,
basically are atoms of same elements which have different mass. Atoms of
okay, ma'am.
same element which have different mass. Let's say, beta, this is an element of carbon. Okay. Let's say it had 3 atoms. Okay. Let's say it had 3 atoms, or let's say it had 5 atoms. Okay. 5 atoms. Out of those
Okay.
5 atoms, beta, one was carbon 12, carbon 13, carbon 14, and carbon 12 and carbon 14 were there 2 times, okay, because it had 5 atoms. Fine. Now, how will I
Yes.
measure this? I will take the mass of all of this and I will take the average value. Are you getting it? That
Okay,
is
ma'am.
clear. I will take the average value, yes. So what does this
Yes.
mean? The mass of carbon element will be the average value like this. Yes. Masses
Okay.
of all the atoms of that element, and we take the average value of that, and that becomes the mass of the element. Clear, beta?
Yes, ma'am.
Beta, this 12, 13, 14 represents nothing but the masses here. Carbon 12 means the atom has a mass of 12 units. And we have seen this why. Because this has been taken as the reference point. Yes. You
Yes.
answered me this, that we divided one piece. We took one piece out of the 12 pieces. Therefore, if we take the mass of the full atom, we have 12 pieces. Therefore, it will come out to be 12 units. Yes.
Yes. Ma'am.
Then we have carbon atom, which also has a mass of 13 units. Yes, beta. We also have carbon atom, which has a equal to the mass of 14 units. Clear? Mass.
Yes.
We take the mass of all of these atoms. We take the average value. Therefore, we get the mass of the carbon element because all of them are ultimately part of this carbon element. Any confusion in this?
No, ma'am. I got it.
Fine. So atomic masses of a few elements: hydrogen, C 1 unit, carbon 12, nitrogen 14, oxygen 16, sodium 23, magnesium 24. Magnesium 24, sulfur 32, chlorine beta 35.5. See, it is written as 35.5 because we have taken the average value. Okay. Let me just quickly explain. There is 35 chlorine, 35. Okay. That means atom of chlorine having mass of 35 units. Okay. And there's one more atom of chlorine that is 37. Okay. 37 units. Now there is some percentage of this and there is some percentage of this. Obviously, I will take the average value and therefore I get it as 35.5. This is the average value. Okay, beta? Average value. Fine.
Okay. Yes, ma'am.
Calcium 40 times. 40 times the mass of 1/12 the mass of carbon 12. Clear?
Okay, ma'am.
Now I'm coming back to the earlier point. See, now I'm coming to, we said what is unit? We know what is unit now. 1/12 the mass of carbon 12 atom is the unit of the atomic mass, right? Now let's understand how
Yes.
do we denote that. Okay. See, we define the atomic mass unit, earlier abbreviated as AMU. Earlier it was written as AMU. Okay. That means atomic mass unit. Okay. But according to the latest IUPAC recommendations, basically IUPAC is the ultimate institution which governs all the, namings and the rulings regarding the chemistry. Okay, recommendations. It is now written as U. It is now written as U, which is unified mass. Okay. Now, what is
Oh,
U, beta? What is U? Let's see. As equal to the mass of one carbon atom, then mhm, assign carbon an atomic mass of 1 U and oxygen an atomic mass of 1.33 U. How is this not right? Basically, now if I ask you what is U, can you tell me what is U right now?
U is the unit.
Yeah. What is the value of this unit? You know. How have we taken that unit?
1/12.
Exactly. Excellent. Wonderful.
Okay.
U is nothing but 1 by 12, the mass of carbon 12 atom. Clear? This is the unit now. Earlier, basically, they took the whole of carbon atom and then they were measuring it. Therefore, we are saying, as one carbon atom, therefore, we got as one U. Okay. But then that was actually discontinued. Okay. Fine, beta.
Okay, ma'am.
Now you should know what is one U. So what will I say the atomic mass of oxygen is? Can you tell me the value and the unit? Oxygen atom, atomic mass of the oxygen atom, beta.
Atomic mass should be 16.
And unit, what will I take the unit as?
It, it would be 1/12.
Yeah, and I have given a smaller quantity to that, right? And I call that as U.
Yes, ma'am.
Can I say the mass of oxygen atom is 16 U, beta? Yes. The
Yes,
mass
ma'am.
of hydrogen atom is 1 U. The mass of carbon atom
Yes.
is 12 U. The mass of nitrogen
Okay.
atom is 14 U. Yes. This U is nothing. You know it. What is U now?
Yes, ma'am.
Clear? Fine.
Yes, ma'am.
Any problem till here, beta?
No, ma'am.
See, Harshita, now whatever we are going to discuss basically is a bit of the historical background. So just keep in mind what have we discussed as of now, what is the actual point as of now, okay? But these are some of the historical developments, so then we have to go through that, okay? Try to understand,
Yes.
right? But don't get confused. Earlier, beta, what they were saying is that you know now that U is this as of now, okay? Earlier, what
Yes.
was the case? As equal to the mass of one carbon atom. Now U is equal to 1/12 the mass of carbon 12 atom, yes? Earlier it was taken, this whole of carbon 12 atom was taken as U. Is it clear?
Okay, ma'am.
Right? So now what happened? The values came out to be different. Obviously, we are taking a bigger unit to compare. The units would come out to be different, right? The values would come out to be different. Yes
Yes.
or no? Okay. So now what
Yes, ma'am.
happened? From that point of view, carbon had a mass of 1 U. That is clear. We are taking this as the reference unit. Obviously, this will have the mass of 1 unit, right? Because this is the unit itself.
Yes, ma'am.
Right? And oxygen came out to be with a mass of 1.33 U. Understood? Therefore, the mass of
Yes.
one oxygen atom was 1.33 times the mass of this one carbon atom. Clear, beta? However,
Okay,
it
ma'am.
was more convenient to have these numbers. See, why was it discontinued? Have these numbers as whole numbers or as near to a whole number. Yes, 1.33, what is this? This was not very convenient. Therefore, we wanted to have whole numbers, okay, or at least near to whole numbers. Then for that, what do we need to do? We need to change the reference point. We need to change the standard value, standard unit. Yes. Therefore, the values will change. What happened? While searching for various atomic mass units, again units, scientists initially took 1 by 16 of the mass of an atom of naturally occurring oxygen as the unit. So let's say this is the mass of oxygen, naturally occurring oxygen. Okay, we don't really know the mass of this. What happens? We take 16 parts of this, okay, and then we take this 1 by 16 part as the standard unit. Very similar to what we are doing right now. Okay, what we are doing right now. And why was this done? Because oxygen was very convenient. Why? Oxygen reacted with a large number of elements and formed compounds that we know. Oxygen is almost present in every compound. Okay. This atomic mass unit gave masses of most of the elements as whole numbers. This is what we wanted. This is what we
Yes.
wanted, whole numbers. But this was discontinued and we adopted, what did we adopt as the standard unit? We took 1/12 the mass of carbon-12 atom. Is it clear, beta?
Yes, ma'am. Ma'am, why wasn't 1 by 16 taken?
Just, basically when we experimentally conduct we conduct the experiments, let's say if we were taking 1 by 11th, okay, of the oxygen mass, okay,
Okay.
mass of one oxygen atom, we were not getting the whole number values. That was the problem, okay. Whatever part is giving us the actual values that we need in a manner that we need, okay, that part is clear. Is it clear?
Okay, ma'am.
Does it make sense to you? Is it understood to you?
Yes, ma'am.
Harshita, quickly go through this atomic mass part and tell me any problem, any silly confusion. I would welcome that, please.
Okay, ma'am.
See, this topic is actually very important. It becomes fundamental to solving all other chemistry, advanced chemistry. Okay, atomic mass plays an important role.
Okay, ma'am. Yes, ma'am, I'm sorry.
Done?
I'm
Understood?
confusion. I
No
understood
confusion?
everything. No, ma'am.
Harshit, I'm quickly going through the three atomic mass units which were taken so that you are able to understand them again. Okay. The first one that was taken, okay, this is one carbon atom. Okay, one carbon atom. They did not mention what is it, just one carbon atom. Okay, and this was the standard unit. This was the standard unit. And when we compared with this, okay, the mass of oxygen atom, okay, 1.33 times this, okay, 1.33 times of this. Is it understood? I hope it is not very confusing.
No, ma'am. I understood.
So this became the unit, okay, this became the unit. Now this was discontinued because it was not giving the masses of other elements and whole numbers, and that is not very convenient, okay. Then what was the second thing that we did? We took oxygen atom. Okay, we took oxygen atom. We divided this oxygen atom into 16 pieces. Okay, let's assume this was the one piece of the okay, one piece of this oxygen atom. Yes, this became the unit. This became the
Oh,
unit. Are you getting it?
yes.
Let's say I'm just saying it was not the actual value. Let's say in with this as the standard unit, okay, the mass of nitrogen came to be 9 units. Okay, what does this mean? 9. Okay, 9 of these, okay, will be equal to the mass of one nitrogen atom. Is it understood?
Yes, ma'am.
Then actually, eventually, what was taken? The third and the actual one, the eventual one, what was taken? This is one carbon-12 atom. Okay, okay. This piece, that is 1/12 of this. Okay, 1/12 of this, and this was taken as the unit. This is one unit now. This is one.
Okay, ma'am.
Whatever masses I measured now for other elements, that was taken in reference to this. How many times of this one unit? Is it understood, beta?
Yes.
Any
Yes, ma'am.
confusion? Okay,
No, ma'am.
no. Now we are moving on to another topic, that is atoms, molecules, and ions. Do you have some idea as to what are molecules, as to what are atoms? Because we have discussed this in the second chapter. So I want to know if you have any idea. Could you please share that?
So the molecules, they're the group of atoms.
Wonderful. Molecules are a group of atoms. Excellent.
Then atoms, they're the
Atom is, yes, say that.
they're the basic unit of the matter.
Excellent. Excellent. The smallest particle we have learned right now in this
Yes,
chapter. Wonderful. The smallest particle basically existing. Good. Next.
yes. And they can be divided into protons, neutrons, and electrons.
Yeah, those are the subatomic particles. Fine. Fine. But any other point regarding molecules?
Molecules.
We have learned that molecules are of two types, elements and compounds. Yes.
Yes, ma'am.
So what was the point, the differentiating point there? That the elements have the same type of atoms. Although it's a group of atoms, it's a molecule, but same type
Yes,
of atom. Compounds have different types of atom. Yes,
yes,
different types. That became the compound. Although that is also a molecule, the only point is that what are the constituting atoms, right? That was the point.
yes,
So we are just going to study about that. Okay, some brief
yes,
introduction. See, how do atoms exist? We have understood about one atom, the historical developments of that one atom. Okay, about the atom. Okay, the structure of the atom we'll be discussing in the next unit. As of now, we have discussed
yes,
the symbol, the mass, and all of that we have discussed. Okay, now we want to know that obviously one atom is so small that we cannot see that. If you are seeing the matter, that seriously means that many atoms would have combined together to give you that, right? Now we need to know why and how does the atom combine and why can't the atom exist on its own just as a single atom. Understood? That we are going to finish.
yes, ma'am.
Atoms of most elements are not able to exist independently. Atoms form molecules, important, and ions. What are ions, beta? Charged species. You must have this idea, right? What are ions? Charged species, yes.
Yes, ma'am.
You know this? Charged species. Fine. These molecules or ions aggregate in large numbers to form the matter that we see, feel, or touch. Okay. Let's say, let's say, beta, I have a teaspoon of sugar. I have a teaspoon of glucose. Okay. What is that?
Yes, ma'am.
What is this? Hello?
That is glucose. Yes, ma'am. I can hear you.
Okay, okay,
Ma'am.
fine. Glucose. Okay. This is
Ye-
glucose. Now, how do I write the structure of glucose? Something like this. The formula
Yes,
C6H12O6, right? This is
yes,
one atom. This is one molecule of glucose, right? How
yes,
many
ma'am.
atoms are here in this one molecule of this? Will I say that carbon atoms would have combined with hydrogen atoms and with further with the oxygen atoms, right? Yes or no?
Yes,
And if I
yes,
say the matter that we are able to see that one teaspoon of glucose, definitely many molecules of this would have combined. Do you agree with that?
yes, ma'am.
And in this also, one atom is not there. It's a group of atoms which is being repeated. Clustered group of atoms. Do you agree with this?
Yes, ma'am.
Fine. Good. Fine. So this is what we have understood here. Now see, what is a molecule? Molecule is in general a group of two or more than two atoms. The point is that even if there are two atoms, it's a molecule. That's it. We are not concerned. It could be more than two, but even if it's two atoms, it's a molecule. Clear? That's the defining point. That are
Okay, ma'am.
chemically bonded, already discussed in the last chapter. Chemically bonded, yes. Chemically
Yes,
bonded together, that is tightly held together by attractive forces. We have discussed this
yes,
intermolecular forces are attractive in nature, yes. When they are holding to each other very tightly, that is what we mean by a chemical bond in simple words. A molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence. Why are we saying this? Hmm. I think in the second chapter, we discussed this very important point that ultimately elements are the basic form of matter. Yes. Now we are saying is the molecule which is the basic form of matter. Which one is the correct one?
and I think it's molecules.
Hmm. So then that statement is wrong. Yes,
Ma'am, can
beta.
you hear me?
Yes, yes, I can hear you. I'm saying then that statement is wrong, which is saying that elements is the basic form of matter.
Ma'am, your like screen is like just lagging. Your camera off.
I think there are some network issues. I think
Ma'am,
let's
can you hear
continue
me?
like this. Yes, 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 I can hear you. Hello.
Okay, ma'am. Now I can hear. Now I can hear
Is
you,
it
ma'am.
Is it okay now? Should I say something?
Yes, ma'am. You can talk now. I can hear you.
My point is that here we are saying that it is the molecule which is capable of an independent existence, right? The smallest molecule. Here, it's
Yes,
the smallest particle is molecule which is capable of independent existence. In the second chapter, we were saying it is the element which is the basic form of matter.
yes, ma'am.
Either both the statements are right, either one is wrong, and then which one is wrong?
And I think molecules are the
Mhm. So then
basic.
whatever we discussed in the second chapter, that is a wrong point.
Ma'am.
Then
Like molecules together, they form elements. So that is
molecules
also.
together they form element, huh?
And like the same molecules joined together, they form elements.
Beta, elements are nothing but molecules. Yes,
Yes, ma'am.
elements are nothing but molecules.
Molecule.
Okay, see, a molecule can be defined as the smallest particle of an element, yes, or a compound that is capable of an independent existence. See, what happens like this. If I say, beta, this is one molecule of oxygen, yes or no? Say yes or no. There are two oxygen atoms here. Clearly, it's a group of atoms. Clearly, it's a molecule. Do you agree with that?
Yes,
Right? And this is, if I have many of these, what is this? This becomes an element of oxygen, right? This becomes an element of oxygen, right? In this element of oxygen, which one is the smallest part and like unit to be existing here? Can I say it is the O2, which is being repeated,
yes,
right? Therefore, what is this?
yes,
Is this a molecule? Yes or no?
yes, ma'am, it is.
Therefore, here in the case of element, the molecule is the smallest unit to exist independently, the smallest particle to exist independently. Is it understood?
Oh,
Let's take any other example. Let's say this is water. This is again water, water, water. This becomes a compound of water. Yes. What
yes,
is
ma'am.
being repeated here? H2O.
H2O.
What is this? What is the smallest particle here? It's H2O. That is why H2O
Yes,
is being repeated. Had it been hydrogen, it would be hydrogen which would be repeated, right? Therefore, it is
yes.
nothing but a molecule. See, there are three atoms. If there are three atoms, it's a molecule.
Okay, ma'am. Can you hear me? I can't hear you.
Yes. Is it better now, beta?
Yes, ma'am. It is better now. But your presentation, ma'am.
Yes, yes. I stopped sharing that.
Okay.
Fine. So it's a molecule. What is H2O? There are three atoms in total. So therefore,
Yes,
it's a
ma'am.
group of atoms. Therefore, it's a molecule. Is it understood?
Yes, ma'am.
Now, molecules of elements. The elements you just understand when the same atoms are combining together to form the molecule that is element, right? That molecule is called as the element. See, the molecules of an element are constituted by the same type of atoms. The molecules of an element are constituted by the same type of atoms. Molecules of
Yes,
many elements such as argon, helium are made up of only one atom of that element. I will discuss this point later after discussing oxygen and ozone. See, a
yes,
molecule
ma'am.
of oxygen. Hello.
Yeah, ma'am.
Yeah,
I
okay,
can
fine.
hear you.
Network is just too problematic. Fine. A molecule of oxygen consists of two atoms of oxygen. We have seen this. This is a molecule of oxygen, right? This is a molecule
Yes,
of oxygen. And hence it is known as a diatomic molecule. This is a molecule of oxygen and it consists of two atoms of oxygen, right? And it becomes one
yes,
molecule. Focus on the terms I'm using. Two atoms of oxygen gives you one molecule of oxygen, right? And this one molecule is nothing but a molecule of the element of oxygen. Element of oxygen. Yeah. Why are we saying element of oxygen? Because this element or this molecule is formed with the combination of same type of two oxygen atoms. Do you get it?
yes, ma'am.
Therefore, also it's a molecule, but what kind of a molecule? It's a
Diatomic molecule.
element. Okay, it's an element. Now, in that element, we can see that for every molecule of the element, how many atoms are combining together, and that is called as the atomicity. The number of atoms constituting a molecule is known as its atomicity. Okay. So if I talk about this beta, this is one oxygen molecule. Yes. Just tell me yes or no.
Yes.
How many atoms of oxygen have combined together to form this one molecule of oxygen?
2 oxygen atoms.
Therefore, the atomicity of this molecule is 2. Clear? Therefore, it
Okay.
is a diatomic molecule. Di means 2. Mono means 1.
Yes.
Di means 2. Tri means 3. Tetra means 4. Okay, like this you can understand. Now
Okay.
coming back to this, molecules of many elements such as argon, helium are made up of only one atom of that element. Clear? We know that they do not combine. They are inert gases. You must have heard of this, inert or noble gases, right? They are basically unreactive. Therefore, they don't really combine with other atoms. Okay? Let's say beta, this is helium. Okay, this is helium. This is helium. This is helium. Can I say this has become an element of helium? Right? What is element? Nothing but a molecule. Now, how many atoms of helium are combining together to form the molecule? If this we are taking as a molecule, how many atoms are there? Just one atom. Yes.
Yes.
Therefore, monoatomic. Therefore, monoatomic. What will be the atomicity here? It will just be 1. Is it understood?
Yes.
Fine.
Yes.
Okay. Therefore, argon is monoatomic. See, any inert gas would be monoatomic. Argon, neon, helium, all of that would be monoatomic. Helium, monoatomic. Oxygen, diatomic. Yes. Hydrogen, diatomic. See, how do we write hydrogen? H2. Yes. This is a
Yes.
molecule. What kind of a molecule? Element. And to form one molecule, how many atoms are required? 2. Therefore, the atomicity becomes, it is diatomic and therefore the atomicity is 2. Okay. Atomicity is diatomic molecule. Clear? Nitrogen we
Yes.
write as N2, diatomic. Okay. Chlorine we write as Cl2, diatomic. Yes. Phosphorus, tetra means 4. Therefore, this is one molecule of phosphorus, P4.
Okay.
Sulfur, polyatomic, although beta it is sulfur as 8. So 8 is atomicity, but we just take the term as poly because like it's too much of them. So we just write polyatomic. Poly means many, simple.
Like
Okay.
more than 4.
Yeah, more than 4. More than 4 we can take as polyatomic. Okay.
Okay, ma'am.
Any confusion here?
No.
I'm stopping it here today, Harshita. Uh, hope I think in the next class you want the revision. Okay, we'll continue with the revision then. But go through this, okay? Because if you would not revise it, it's of no use today. Okay. Today's class would be of no use. So then
Okay,
revise
ma'am.
this, then
Sure.
we will take the revision point then, okay?
Okay, ma'am.
In the next. Any other query, Harshita?
No, ma'am. I got it.